Okay, so what we're doing in this recording is the examples from the constructions of the special parallelograms. As you see from the note that these constructions do not require new skills. Really what we're going to do is use all of our previously acquired skills, and we are going to apply those to the special quadrilaterals, and in order to do that we're going to need to know the properties of the special quadrilaterals. So we're going to begin by constructing a square that uses AD as a side. So effectively what we need is 90-degree angles at A and at D. Then we can copy the length of AD for both of those, and then we'll be able to close that out as a square. Okay, so I'm going to start by extending my side AD on both sides, and I'm just going to shift that up a little bit. Just make sure I get that on there. Okay, so what I've done is I've extended on both sides, and now what I'm going to do is construct 90-degree angles at both A and D. And in order to construct a 90-degree angle through A, what I'll start by doing is just creating an arc either side of A and equal distance from A. And I'm going to repeat the exact same construction at point D because I need a 90-degree angle there as well. And so I'll just try and be efficient here. So mark both of those off. The next part of the construction involves going to the point on the extended line, and then what I need is to have an arc above point A, if you will. And so I'll create one arc there. Using the same opening, I will find the point of intersection between those two, and then if I go from A through that point of intersection, I should have created, if I've been accurate, a 90-degree angle at A. So using the same opening again, I'm just going to go and repeat that construction at point D. So I have my one arc and the second arc. Okay, so what this should guarantee for me is that I'm going to, once I construct a segment from A through the point of intersection, that I have a 90-degree angle, likewise at point D. And so what I'm going to do now is work out how big the sides need to be. So I'm going to measure side AD. Okay, once I'm confident that I have the measure of side AD, I'm just going to mark off that length on both sides, because of course squares have got all four sides congruent. So if I mark off those two sides over there, I should now be able to close out my square as follows. So what I'll do is I'll just shrink that down quickly, see if I can get this to align accurately. Okay, and so what I'm going to do is go from point A through the point of intersection that creates my 90-degree angle and stop at the arc, which will guarantee the length is the same as well. And so we'll do that. And likewise on the other side. Let's get my ruler to align, and then okay, and then the final piece, of course, what we should have guaranteed at this point is that we have 90-degree angles there and there, which guarantees these two are parallel to each other, should also guarantee that they're equal. So that gives us a parallelogram already, one pair of opposite sides parallel and equal. And then if you add in the 90-degree angle and the fact that we have adjacent sides congruent to each other, if we close that out, that will create a square for us. And so let me just go to the point of intersection as accurately as I can. And just rotate that ruler. Okay, and then what I'm going to do is just close out my square, and that should give you a square with side length AD. Alright, what we're going to do now is move down to the second construction. Here we're being asked to construct a rectangle using AB as one of the sides and half of AB as the second side. So very similar to what we've done above, only we do need to bisect AB in order to find this length for the other sides. Okay, so what I'll do is a similar approach. I'm going to start off by just extending either side of AB so that I'm able to do the 90-degree construction once again. And so I'm going to repeat that process as above. So we'll just go through that. And so once again, markings either side of the point. And since I'm doing the same thing on the opposite side, I'll go ahead and do that now with the same opening. And then what I need to do is go to those openings, ensure that I can create an arc above B, and using the same opening, repeat that process on the other side. Okay, and I'm going to go over to A and do the same thing. Okay, now what this should allow is for me to have created 90-degree angles at A and B, which of course is a characteristic of a rectangle. So what I'm going to do is I'm going to go ahead and just draw the side, and I'm going to make that just about as long as I can. And then the last piece really would be for me to go back and then figure out half of the length of AB so that I can get my other side to be correct length. So in order to find the half of the length of AB, what I'm going to do is the football construction effectively. And what I want to do is perpendicularly bisect AB in order to find its midpoint. And so let's just shrink that down a little bit so that we don't have too big a problem here. Okay, and so I'll do my first arc, go to the opposite side, rotate round and close that out. And again, what I'm interested in this case is just the midpoint. And so I'm going to rotate that round, line it up, and I'll just use a dashed line here, which would have joined those two, but in particular what I want to make sure is that I have marked off that point over there, which should be the midpoint of AB, which is now going to allow me to measure that length. So I'll measure that length, which should give me half of the measure of AB, and then I'm going to mark the other two sides as half of the measure of AB on either side. And at this point I should be able to close that out and have a rectangle with the required specifications. Okay, and last example, we're now going to construct a rhombus using AB as a diagonal. And so if you know the characteristic, as you well hopefully should do, then you'll know that the diagonals of a rhombus bisect each other, and they do so at 90 degrees. Okay, and so effectively what we need for AB is once again the football construction. We need the perpendicular bisector of AB, and let's go ahead and do that. So I'm going to use the football construction open to more than half, and I'll use a different color now because my constructions are going to overlap, unfortunately. I'm going to perpendicularly bisect. Oh, change that opening, unfortunately. I have to redo that. And go back to the other side, make sure I do not change the opening this time. Okay, and what we've effectively done here is we're going to be able to perpendicularly bisect, which gives us our 90-degree angle, but we can also use the point of intersection. Those are going to be an equal distance from each other and from AB, and so that will give us our other diagonal, and it'll give us our other diagonal as a bisected segment as well, which will help us. See if I can get that to line up. Okay. And so what this has done, or what this should have done if I've done this accurately, is not only created my 90-degree angle here, but it should have guaranteed that those two pieces are equal, those two pieces are equal, and really all I need to do at this stage then is to close out my rhombus, which will be, I can do by constructing the sides. Okay, and that should give you the construction of a rhombus using AB as a diagonal.